Hello. Now we continue with our discussion, which is the correction of the test that you guys just did. Now we are moving on to the second question because in one previous lesson we discussed question 1, and question 1 was divided into parts like 1.1, 1.2, 1.3, all the way to the last. So here we continue with the discussion of the test and we move on to question 2. Now question 2, as we will be seeing, is in section A, and it is requiring us to apply our knowledge of simplification, to make things simple. So right away, question 2 is right here, and question 2 is also divided into 4, divided into parts and up to 4 parts. The first question is that we write down this ratio of 50 centimeters to 3 and 1/4 meters in the simplest form. So this is like trying to say, in simple terms, it's like saying for every 50 centimeters, there is 3.14 or 3.25 meters, okay? So how do we then simplify this? Well, when we are comparing two quantities, it makes sense that we first simplify them. Rather, it makes sense that we write them in the same unit. Now, notice that this one is in centimeters, okay? Then again, this other quantity, that is 3 and 1/4, is in meters. So what do we do? Well, the right way of simplifying or to ensuring they are in the same unit is to convert these meters into centimeters. And what relationship do we have? Well, we know that 1 meter is 100 centimeters. So that means in the simplification, we can then write 50 centimeters, okay? 50 centimeters, just enter this. 50 centimeters to what? 50 centimeters to 3 and 1/4, 3 and 1/4, 3 and 1/4. Like this. So to convert it to meters, we have to multiply this by what? By 100. So now we have converted it from centimeters, rather from meters to centimeters. So 3 and 1/4 is the same as well in fraction. Just put this as the next step. We have in 50 centimeters to what? Now 3 and 1/4, not 3/14. Just change this a little bit. This is 1/4. Like that, yes. 3 and 1/4, not 3/14. So that's what we have. So now what we have got to do here is to convert this to proper fraction. So this is like 4 times what? Times 4 times 3 is 12. Then 12 times what? 12 plus 1 is going to be 13. So it's like 13/4. So we'll be dividing it right here. 13 divided by 4. What do we get? We get 3,25. So what do we have here? We have 3,25 that we have to multiply with what? 100. So that we get it in what? In centimeters. So what will that be in the next step? Well, this is going to be 50 centimeters to what? 50 centimeters to, well, 3,25 times 100. 3,25 times 100 gives us 325. 325 centimeters. So now after reaching this stage, that all the quantities are now in the same unit, the next thing you want to do is to find a way of simplifying it by like dividing, by like reducing. So you want to find out, is there a number which can divide 50 and also 225? Is there a number which, so that you keep reducing like that? Okay. Well, the easiest way to deal with this is to try to find out if there is a number, if 50 can divide 225. Okay. So what do we have? We have 50 centimeters. Now, before that, rather, can 50 divide 200, 325? Well, let's check. 325, can it be divided by 50? No, it cannot be divided by 50 because it will give us decimal points. We don't want to deal with the decimal points in reducing this. So the next thing to do is to try. Now, since 50 cannot divide 200, rather 325, which other number can divide 325? So what we do now is we divide this one. So we reduce it a little bit. Like we divide this by 25 so that we get 2, and then we check, how about 25? Can 25 then divide 325? Okay, because we tried with the 50, it's not working. So we would like to try with half of 50, okay? We reduce the 50 into 2. So what is half of 50? Half of 50 is like 25. So now we want to check with the 25. Can 25 divide 325? Let's check. So we have 325 that we have to divide by 25. 325 divided by 25, yes. So yes, it's 13. So that is working. So what's that supposed to give us? That's supposed to mean, because when we divide 50 by 25, we get 2. Then now, when we divide 325 by 25, we get 13. So in a simplified way, 50 centimeters to 3 and 1 out of 4 meters can be reduced to 2 to what? 2 to 13. That is the answer to this question. That is how you would write down 50 centimeters to 3 and 1 out of 4 meters in the simplified or in the simplest way. The next question is question 2.2. And in question 2.2, we are supposed to write down the highest common factor. Now, notice that finding the highest common factor, the HCF, can also be done with a calculator. You can just use the calculator to do that, but sometimes it is required that you show the steps. Now, the thing with the calculator is that you will not be having the steps easily displayed. And because you will not be having the steps easily, just plugging in my cable. All right. So because you will not be having the steps shown, all of it, when you're using a calculator, it's important that you get also to know how to use this, how to solve this without the use of a calculator. And so how can we handle this without the use of a calculator? Well, without the use of a calculator, let's use a table. Yeah, something like this. Okay, so we just make it small, like that, and this. Okay, so just need to add one more. Has got to be 3, like this. And just a few more, then we just do what? Yes, and Just trying to put something briefly in order. Yes. This is what we are dealing with. It's like that. Yeah, basically just that. So now, the thing we want to deal with is what? We want to find the highest common factor. Here we have 72, and here we have 720. The highest common factor is like the highest number or the biggest number which can divide 72 and 700, rather not 720, 120, sorry for that. Yes. So we would like to find out which number can divide 72 and also 120. And the other thing is, this number that we are talking about must be the what? Must be the highest number, because there are obviously many numbers that we can what? That we can use. So let's check with 2. Can 2 divide 72? Yes, 2 can divide 72 and we get 36. Can 2 divide 120? Yes, 2 can divide 120 and we get what? We get 60. So you see, 2 is a factor of 72 and 120. Now, can we try again with the 2? Can 2 divide 36? Yes, 2 can divide 36 to give us 18. Can 2 divide 60? Yes, 2 can divide 60 to get what? To get 30. Then we again check with 2. Can 2 divide 18? Yes, 2 can divide 18, and that will give us what? That will give us 9. Then can 2 divide 30? Yes, 2 can divide 30 to give us what? To give us 15. Well, again with the 2, can 2 divide 9? No, 2 cannot divide 9. We remove it. Then we check with 3. Can 3 divide 9? Yes, 3 can divide 9 to give us what? To give us 3. Can 3 divide 15? Yes, 3 can divide 15 to give us 5. You see? So basically, these are the factors. Now, the common factors of these two numbers, okay? So now in the final expression, we say the highest common factor, okay? The highest common factor of these two numbers, 72 and what? And 120 is what? Is 2 times 2 times 2. How many 2's do we have? We have 1, 2, 3. Yes, we have 3. Then what else do we have? We also have 3. Like that. And we simplify it as this. 2 times 2 is 4. 4 times 4, rather 4 times 2 is 8. And 8 times 3 is what? Is 24. Yes. So this is how you find the highest common factor. You could also use what is called the factor tree. The factor tree can also work without any problem. But knowing how to get here is very important. Well, the calculator can easily give you the value, but sometimes you are required to show the steps clearly. And so this gives us 24 as the highest common factor of 72 and 120. Now, the next thing we want to deal with is question what? Is question 2.3. And what is question 2.3 saying? Well, question 2.3 is saying that we write down this one as a product of its prime factors. Then also we show the working. So writing one number as a product of the prime factors means we have to write that given number as some other number times, other values. So how do we get there? Well, to get there, we also use this method here, okay? We use this method of finding the LCM or the HCF, which is the highest common factor. So there we go. We have got to insert a table. Yeah, something like that. Add more later. So what's the number? The number is, oh, before I write the number, just clear this. Yes. So the number is 1485. So we will start by checking. Can this number be divided by 2? Let's check 1485. 1485. Can it be divided by 2? No, it can't. So we again check 1485 divided with another number, this time 3. Can it be divided by 3? Yes, it can. So the first is going to be 3. When we divide this number by 3, what we get is what? Is 495. So we write it down as 495. Now, we would like to check which number can divide 400 and what? And 95. So 495, we would like to divide it by what? 2 will not work this time. We check again with 3. Yes, it gives 165. So by 3, it gives 165. So can we divide that by 3 again? Well, let's see. We divide this by 3. What do we get? We get 55. So here, we divide by 3, then we get 55. Yes. Then now, can we divide 55 by 3? No, 55 cannot be divided by 3. You can just see for yourself here. It can't work. So we divide 55 instead by 5, so that we get what? We get 11. So we divide this by 5, and what do we get? We get 11. So then, lastly, we divide this by 11, and we get what? We get 1. So this one as a product of the prime factors will then be, that is 1485 as a product of its prime factors is going to be 3, okay, times 3 times 3. That is how many 3? 1, 2, 3. Then times 5. Then times what? 11. Or you could also write it as what? You could write it as you could write this as, let's reduce some space here. We no longer need this one, so just remove it. Yes, so we could write this as 3 times 3 times 3, that is 3 cubed. 3 cubed times 5 times 11. The cube is written like this. Yes, like that. So 3 cubed times 5 times 11. You could stop here, it's fine, or you could write like that. So that becomes the what? The answer to question 2.3. Then the last question is asking for us to subtract. What are we subtracting? Well, we are subtracting 4x raised to power 5 minus 3x raised to power 2 plus x from this one. What this means is this quantity will come first. This one here will come first. In other words, we'll be having 7x squared. Okay, 7x squared. That we have to do what? Plus 5x minus 4x cubed. 4x cubed, is it? 4x raised to power 5 instead. 4x raised to power 5. Yes. Then from this one, we have to subtract this other quantity right here. We have to subtract this one from that. So it will be minus, well, it's going to be safer for us to have what? To have a bracket. So we'll be having 4x raised to power what? Raised to power 5. Then what is next? Next is minus 3. Minus 3x squared. Minus 3x squared plus x. Yes, like that. So what we have just done is just we have written, you know, you could also have the bracket for this. Like that. So basically, we have transformed this equation. We have transformed the statement subtracting this from that into a mathematical expression which we can now deal with. You know, we can now deal with this. Okay, so now you notice that before we begin the process of subtraction, we have to open the bracket. We have to open this bracket, and we also have to write this one down. Then after opening the bracket, the next thing that we want to do is to collect like terms, is to place terms that are similar together. Like where there is x squared, we put another x squared. Where there is what? X raised to power 5, we put another x raised to power 5, okay? So basically, what we are going to be doing here is this one will stay the way it is. Right there. Then, the only problem is going to be this one. This one will not stay the way it is. The sign before them will change, okay? The sign before them will change. And how will the sign change? Well, this 4 will have a negative sign because it's like we have a negative 1 right out there. So negative 1 times negative 4 is negative what? Is negative 4. Then negative 1 times negative 3 is what? Is going to be positive. Because negative times positive is, rather negative times negative is negative. Then negative 1 times negative 1 times x, that is positive, is going to be what? Is going to be negative. So yes, this one will be negative. Now that is where we have reached, okay? So the negative outside the bracket, which is this one here, negative 1, has affected this 4, has affected this negative 3, and has also affected this plus here, plus 1. Now, what else is left? What is now left is for us to do the grouping, the collection of like terms. So here we have what? We have 7x squared. So in the next step, this 7x squared, what's this? In the next step, this 7x squared that we have got up must be written close to another 7x squared, which we also have right there. Yes, so this 7x squared has got to be written close to this other one here. So we put them together like that. We are now at least with this one and that. So now we begin to group the what? This 5x. So this 5x has got to come close to what? Has got to come close to this other x. So we'll be putting it here. That is plus the 5x. And we also have what? We have minus x there. Minus x. Yes. Now the next thing is the what? Is this one here, which is 4x raised to power 5. So we say 4x raised to power 5. That is 4x raised to power 5 Then we also have what? We also have this other one here, which is another 4x raised to power 5. X raised to power 5. Yes. So that's what we have. Now, what's going to be the next step? Now, the next step in this case is going to be to add. So we will add the numbers in front. We will not add the letters, okay? So 7 plus 3 is what? Is 10. 7 plus 3 is 10. We keep the what? We keep the x squared the way it is. Then after that, the next thing we want to deal with is the 5 and the what? And the 1. So 5 minus 1 is 4. So we will be having 4x. Then after that, what do we have? We now have these numbers here, which is -4 minus 4. Okay, what is -4 minus 4? That is -8. You can even see it from here. -4 minus 4. This gives what? -8. So you'll be having the number in front as -8. And then we'll be having this x and this x raised to power 5. We just keep it there. X raised to power what? Raised to power 5. Like that. So in conclusion, what did we do? Well, the question was that we subtract this quantity here from the other. To subtract something from the other is like you take away something from what is already there. What did they give us? They gave us this one. So we have to take away this from the other. So that means we have to write this quantity first. And from it, we take away this other quantity. And when we do that, we will notice, because we are subtracting, the element of subtraction or the minus sign will affect the what? The 4x raised to power 5 and the 3x squared and the what? And the x, as indicated here. Then the next step is to group or collect like terms. And when we collect like terms, what we get is going to be 7x squared plus 3x squared, then also 5x minus x, then minus 4x raised to power 5 minus 4x raised to power 5, which simplifies to this. And this becomes the what? The final answer to the question. And yes, this is where we stop. Until next time, next question comes for the next what? For the next lesson.